Welcome to episode 17 of Data Mesh TV. Today, I am excited to have my guest, my friend Vincent Caldeira, CTO over at Red Hat. The topic today is OS climate. It's something that I am personally very excited about, something I'm trying to get more involved in. And we are going to bring it back to Data Mesh, but here's what I want you to think about. We're going to talk about some big global topics today. The big global topics that we're discussing are relevant, I think, for any organization. So imagine that we have a big global problem like climate. And in order for us to solve this big global problem, we need to find a way to share more data. We need to find a way to integrate and make more data useful. We need more people. We need better platforms. We need ways of sharing, ways of working, and then ways of consuming all that data and putting it into the right analytics tools so that we can drive actions immediately. That's a big problem. And that's the way, and that's the approach, if you will, that OS Climate is taking. They're taking a lot of people, they're taking open source technologies, they're bringing them together, right skill sets, right tools. They're solving data platform problems so that teams around the world, countries, finance organizations, and businesses alike can use that data to start to kind of create their own answers to their own questions and drive forward better climate decisions. So it's really exciting. I don't think that, and in fact, I would say differently, what Vincent is doing here, and Vincent is building a data platform, I think is something that's really useful for anyone that's thinking about a data mesh, because the approach that he's driving, the way that he's thinking about it makes a lot of sense for any company. So Vincent, welcome to the show.
Hello, Adrian. Thank you. Happy to be here today.
Awesome. I know you and I met in Singapore, and I think it was over a very nice dinner. It was really good food. I couldn't stop talking about OS climate, and I said, "Oh, it's exciting!" And I think after about an hour, you found a way to hide from me. But thank you so much for joining us, because I think it's a fantastic topic. I've gone online and watched a couple of videos. I watched the UN video where you were at, I think that just recently at a UN conference where you were talking about OS climate to a number of different people. And so in that session, there were a lot of quotes that I took, things that really inspired me about your approach, really inspired me about what you're trying to do. And so I'm going to take those quotes and we're going to kind of talk through some of those points and probably add a little more color to it. Yeah. One of the first things that was discussed, Vincent, in that session was the idea of an open data platform, right? Open data platform. And there was a description of what that meant, but let's hear it in your own words. What does that mean? You're in charge of the common data side for OS Climate. What do you mean by open data platform?
Well, so the first thing you should look at is really who are your user and how do they typically need to consume data. So if you look at the community of scientists or people even in the investment community who are trying to build a tool, in particular risk modeling around climate, these people are not necessarily technology people. They may not be aware of the latest technology to heavily process distributed data such as Spark. They may not be able to access streaming data easily from IoT device or from satellite imaging. So if you start from your consumer, you will realize the first requirement for openness is to have a simple way for people to find data first, and then to query the data in a scalable manner, but using very simple language, right? And so from this angle, I would think the first aspect of being an open data platform is to be able to provide a single, simple layer for almost any data consumer to access data. Obviously, in our case, if you look at the technology side of the solution, we use a federation layer with Trino and really very simple SQL access to do this. But why this is a powerful construct is because in the process of federating the data and providing this layer, we've made it a lot simpler for people who don't necessarily have tech skills to just go and identify data and integrate it within their own modeling, their own business intelligence tools and so on. So that's kind of the starting point. Then, of course, from there, you have to think about how do you even provision those capabilities in the first place? And that brings us to the open data platform. So when you hear me talking about like open data platform, I'm more focusing on the platform aspect of it than the data, to be honest, because not all the data in the climate space is open data to start with.
Sure.
Some data is only available commercially, and therefore we can make it easier to consume. It doesn't mean we can always open all the data that we have access to.
Fantastic. I think when I first heard about OS Climate and the OS parts of the first interesting piece, open source. I mean, you think of open source, you think of innovation, you think of Red Hat, all us gray hairs, right? That's how we started, right? Yeah. And so I innovation led by a global community of open source professionals like Red Hat, like Trino. And so you're talking about a committed community of experts, of skilled experts coming together to solve a problem. And open source means you're going to use the best technology. Open source means there's really no boundaries, right? There's global open source communities that really cross any country boundaries. And then you're able to bring a solution forward to teams. And then you think about the open data aspect. As you said a second ago, a lot of that data is commercial. A lot of that data is hard to get to, right? Some of the videos that I saw, I hear different people offering data sets, and I've seen some use cases that I've read online where teams are bringing use cases to you, whether it's vulnerability models that you can bring into the OS Climate model, or whether it's actual data sources. Somebody said, hey, I've got wind farm data. Hey, I've got NGO data. I've got different data from different places. You can bring that data together. And here's the trick, right? Because here's the challenging part. And following one of your quotes, you said, hey, I'm going to totally misquote you, Vincent, so forgive me, but something along the lines of, data moves too fast, right? If you can imagine all the climate data that we need right now to start to create meaningful actions, what do? Do you go out and grab it and bring it into one place, or do you need to move faster? And I think you said you need to move faster. And so you apply a federated approach. You mentioned Trino a second ago. Talk to me a little bit about the different types of data sets that are being brought to you. It's fantastic that they're making them available, but I can only imagine it's probably everything under the sun.
Yeah, so you raise an interesting point around the open source approach. Now what I always like to explain is open source is really a collaborative approach to developing software. Now, the obvious role of open source in OS Climate is we have open source, what we call the data commons, which is the platform itself. So people can literally take this blueprint and reproduce it anywhere, and they would have exactly the same federated capability, the same self-service infrastructure that we have in OS Climate. But beyond this, I think the more powerful construct is that we are applying this open source approach to the data itself. So if you look at one of the key principles I often mention, which I call data as code, the way we looked at it is, hey, what if we could use the open source principle to share how we actually access the data, ingest the data, transform the data, build data catalogs. All these different steps are actually codified into open source repository, which means that you can take my data recipe and you can reproduce it independently on your own infrastructure, and you will get the exact same data outcome that I have. Now, it's a very powerful construct, because if I extend it beyond climate, we do work with a number of university and people who do research as well. In the OS Climate community, we actually have an academic board as well that reviews, kind of the methodology on how we build models and acquire data. And one key issue that these people typically face is, let's say they spend a year and a half, 2 years doing a research and sharing it with people across the world. The first thing that you'll want to do is, am I able to reproduce independently the results of this research paper? And this is something that when I discuss with a lot of academics, they told me that's very difficult to do. People will go do their own independent study and they'll come with a different outcome because their data is different. And so the fundamental issue we're really trying to solve with this platform is build some efficiency in the process, that you are just provided with the entire, a supply chain of data, how it's been designed, and you are provided with the recipe to build the same supply chain and validate independently how the data was derived, how it was used into a into a data science model or into a piece of analytics. So that's really the power of this approach. If you think about how it helps collaboration, obviously when people save time reproducing and understanding what someone else has done around the world, then they can much more easily contribute their own ideas or improvement to the recipe, because they are not spending time just trying to get up to speed.
Let's talk about that blueprint. Is there a central platform that I would use? Or is it simply a blueprint that I'm taking, and the blueprint would say, here are the data sources that you can use. So it's maybe a library of data sources, I suspect. Here is the technology approach that we use, a federated approach to connecting data sources. And here are the recipes for coming together with different climate related answers. And so I'm looking at the effect of investments in wind farms over the next 10 years. There's a recipe there.
Yeah.
I'm looking at pension investments and any other, questionable, non-sustainable, investment pattern down the road. They're all individual recipes that I can recreate and adapt on my own. Is that the way you think about it?
Yeah. So we have, at the moment, we have both the recipe, and we have around 35,000 data sets that have been federated over the past kind of 1.5 years or so. So it comes
35,000. When you say data sets, are we talking? So how many different data sources would that encompass?
I haven't made a count, but I mean definitely over 1,000 different different data sources. Yes, some of these are public. They are data that is typically released by maybe government body or NGOs. Only problem being that you would probably need to spend weeks or months of your time to basically identify where the source is, collect the data, obviously convert it to a format or bring it into a lake. So this we've made transparent. It's all there. And then some of these data sets are actually commercial in nature. You would have seen we have commercial data provider as member. S&P, London Stock Exchange Group are part of OS Climate. And so they give some limited access to commercial data set to help the community solve some of these problems. So those are not data sets that are meant to be open data, so to speak, because we get a restricted access to them in the context of OS Climate, a scope of work. But we are actually in the process now of creating another layer of capability, which we call the data exchange. And so data exchange is going to be our key focus in the OS Climate technical team this year. And the data exchange is really our way to start making this data available to the non-OS Climate contributor. Because right now, I would say the data mesh that we have is obviously open to all the OS Climate contributors who are building models and so on. But the idea is to extend this and have kind of an API gateway style access to the data for people who just want to build solution on top of it in a very easy manner.
Yeah, it sounds so incredible. The volume of data sources you're dealing with, the volume of active consumers that you're going to be dealing with, and the impact that you're going to create for those consumers. If I play this back, I think about whether some data mesh approaches that I've seen maybe at banks or pharmaceuticals or large energies or media companies. On the surface, it's not that different, right? I have the need to connect, maybe not 1,000 data sources. I haven't seen that one yet. This is the first time I've heard this, which is amazing. But I've got a need to connect to a lot of different data sources. I have a problem with I'm dealing with traditional business verticals that aren't used to sharing. And so in this case, you're dealing with verticals also in the climate world, different organizations. You got people that are focused on wind farms, people that are focused on solar, people that are focused on technology, people that are focused on compliance. Every one of those data is really valuable, but you could think about that same problem, describe it, and say, yeah, it would be the same in almost any industry that's out there. And what we're talking about is making it very easy, one, for these teams to here's a blueprint for the platform that you can build to solve your problem, number one. Number two, here's a data exchange so you can very quickly find the data you're looking for. And then number three, when you find an answer, share it back. right? And that's I think the most useful part.
Yeah.
We haven't used the word data product yet, so let's talk about the data product. Let me go back and underscore what you talked about the recipe, or I'm not sure if you said it here, but I heard it in the video. But you have a great quote out there where you talk about the recipe, and the recipe is, or the blueprint, which is basically using the federated engine on the back end, being able to bring data forward, being able to then have somebody say, I need that data set, that data set. I got 35,000 data sets, but this data product only needs 10. And I create an answer, and then I share it. And then somebody else has the ability to come in, use that recipe and improve it. And when they improve it, they share it back. I read that, I heard that, and I thought data product. Is that how you would describe that as well? Is that it? Is that your data product?
Yeah, I mean, absolutely. Now, I think the industry always come with certain terminology that, after a while, people will basically refer to. We actually didn't start by calling it a data product. I used to refer it as a data domain.
Yeah.
Now what happened over time is we kind of educated ourselves with the literature, and like how different technical people across the world actually refer to different constructs. Data product came about, and I kind of like data product, and now we are using it. The reason is, with data product, then comes to me the entire supply chain of data behind that result into the finished product. And I think it's actually a very good image, right? Because this is kind of what we're trying to achieve here is we create repeatability in the supply chain of data to get a finished product. Then we look at the quality of the product, and if we feel like, hey, we could actually improve the quality further by getting additional data source, or by doing additional data quality checks across the way, then we will just improve the recipe with results on the finished product, right? So it's kind of this loop of I think reviewing the product quality and improving it in a collaborative manner. I actually kind of like the image a lot. So yes, we've standardized on the data product construct as well now, and you probably find a couple of recent articles where we actually kind of call it data product as such.
On that point, there's something you had said, and again, I'm just going to quote you for the whole session because there's a lot of great Victor quotes out there, Vincent quotes out there, and you were talking a bit about, I think, the transparency. You said that you were talking about the value when, as a data contributor, so I contribute the data, great. Now I have access to the other data sets, awesome. But even more importantly, you said, Vincent, as a data contributor, I have the ability to see what people do with my data. Yeah. That's powerful. And I think even in any data mesh or any organization, when you allow your producers to see where their data is being used, it creates a new level of accountability for data quality and metadata, because now I understand that it's important. Now I understand how it's being used. Now I know where to prioritize. Can you talk a bit more about that transparency and that value?
Yeah. So you mentioned earlier that the problem we are solving fundamentally with OS Climate on the data mesh construct is a problem that exists in every enterprise, and it's totally correct, right? So now, I obviously work with a lot of different industry in my day job, and so I have this kind of conversation very frequently. People look at the past and they tell me, well, we started to build our own data warehouse, and then we were told data warehousing is not great. Let's build a data lake. Then we build a data lake, and now we still have problems like getting data to be used in an efficient manner, and finding data and building knowledge of the data in the enterprise. So you come with a new technology, which is like data mesh. So, I mean, is it really going to help me, or is it just a new term that the industry is pushing to me just to sell me a new product, right? And so what I explain to people is, so the first thing is data mesh is not a technology product or a software. Yeah, data mesh is an architecture. So when people sell you a data mesh, you should be very, very careful, because you can't buy a data mesh.
Right.
You can buy tools, you can buy technology that help you build a data mesh, but most of the hard part of the work is not going to set up the technology. It's going to change the way you culturally approach the data discussion and the process around data in your own enterprise. So what I mean by this is, and you explain it very, very well, in a data mesh type of architecture, the people who actually own the data product, they have full decision on how they should be managing data quality, how they should manage the process of producing and sharing data. And they just have a set of federated governance guidelines that they are supposed to follow. So why this is very powerful is that as the data product owner, I'm kind of keeping a hold on my data, and my job is to help my data consumer. Yeah. So in the process of doing this, I'm building a lot of knowledge of how people need to use my data, which helps me to improve how I source the data and distribute it to start with. In the old days, in centralized architecture such as data lake, this never happens. My experience was people will just fire the data in the lake. My job is done. Let's move to the next project. And then people are struggling with data quality, damn it, I put this data into a regulatory report and now the data was wrong or I didn't use it properly. And now everybody is freaking out about, maybe we shouldn't trust the data or the source of it. And so we're kind of solving this fundamental problem by tilting the role and responsibility in the data process. And so no matter about the technology, right? Because the technology will keep evolving, will keep improving, especially now that most of these solutions are based on open source. I think they evolve like much faster in terms of capability than they used to evolve kind of 10, 15 years ago when all these technology were more proprietary vendors. Not taking a stab at them, but this is just the reality. All these platforms are evolving way faster now that there is a community of contributors on the tech. But this is not even the important part. The important part is really the ownership of the data, the ability to have federated governance in your enterprise, and so on.
Yeah. You also said this isn't a technology. This is a self-service approach, right? And so we talk about, I'm not handing somebody a complex blueprint for a technology they have to build and manage and maintain. What I'm really trying to do is hand somebody a blueprint for building a self-service technology, right? So that organization can skip all the hard work. I don't want to oversimplify it because there's work involved, but they don't have to invent, right? Here's the blueprint for how to connect to the data. Here's the blueprint for where the data sets are. Here's a number of recipes you can already start to use. And the idea here is to enable them with self-service capabilities to go out there and start solving the problems. And you talk about supply chain, right? So in the supply chain, if you can sit back and think about solving a climate problem, solving the pension crisis, or initially the OS climate is driving forward, but even bigger than that, a bigger climate problem, you would say, well, first I've got to get the data. And then I've got to figure out a way to make that data available in an open data platform to a lot of different people. And then I got to make sure that I start to kind of organize this data according to the questions that are being asked. So give me the questions, I'm going to organize the data. But once I'm able to organize data in a way that can start to be very effectively used or very effectively tied to questions, the next big thing is action, right? And then you can start to measure results. But it doesn't work the other way, right? You have to start with the data before you can make any meaningful actions. You can guess on the actions, you can guess on the things you might need to do, but if you're solving this first part of the supply chain, I can get you here. Now there's no more excuses. Now you can start to action from this point forward, so to speak. And I love that approach. The acceleration you're creating is fantastic. Digital sovereignty. You tossed that one just before we started. You got me really thinking about it. I said, wow, digital sovereignty. I like that term. Tell me a bit of in terms of what OS Climate is doing on the digital sovereignty side.
Well, so I think it goes beyond OS Climate, but I think recently we have a new stream in OS Climate which is related to ESG disclosure. Okay. So the problem of ESG disclosure, if I sum it up, is there are a lot of organizations out there, government organization or private organization, especially industry led groups that all think that, hey, in order to solve this problem that we call ESG disclosure, which is how we get corporates to declare some of their ESG DNA, including their carbon emissions, as an example, which is probably the most talked about aspect of ESG disclosure, right? In order to solve this, let's build a central database of ESG disclosure data and some system for people to report it. And because every organization is going to build a central database, we have solved the problem of easy access to disclosure. Now, the problem of this approach is, first, there are hundreds of different organizations who think that they have the one database that will rule them all. So everybody will come to my database and contribute the data. Guess what? This is not going to happen, because different industry, obviously depending on where companies are incorporated, they will probably be mandated to disclose in some form to a specific registry. So the way I started to look at this is, hey, hang on, that's an interesting problem here. And it actually ties back to a wider problem of what we call digital sovereignty and data sovereignty in particular. The problem is that as a corporation, the same way as a citizen, you may be mandated to report some data about your organization to whatever government body or industry body that that is relevant to you. Now, this data, traditionally, it may have to be kept within the remit of the organization that mandated you to disclose the data. And very often, these organizations want to keep the data within their country or their region, if we are talking about the European Union in particular. And they may or may not accept this data to be shared for very, very specific purpose. But in no way they may actually let you take the data out and manage it somewhere else, because that would defeat the purpose of creating a registry to start with. So if you think about it, the federated governance approach to data that we built in the data mesh, it's a very elegant solution to this problem, because you can let the people report in their own country. You can build open policy of data sharing, that literally specify who can actually come into my repository and access my data and for what purpose. And then you can leave the data distributed. The data doesn't have to travel to 500 different repositories just because everybody wants to have the data at some point. You can just leave it where it is, and then you can build the kind of access capability around it, which includes the data controls. So it's a very interesting kind of use case. And then personally, since the start of the year, I have started to get involved with a kind of extended discussion around digital sovereignty, which is, a phenomenon that we see across the world these days, which is a lot of, I would say, countries or the European Union in particular, they are starting to come up with regulations around how they make sure their organization build some sovereignty around the technology and the data and the process by which they operate. So, for example, if you are a critical infrastructure like a bank, like a nuclear power plant, like railways, and you are keeping your data in an American cloud, that not maybe the best from the point of view of the European Union. And they start to ask you for some accountability in terms of how you would deal with a situation where maybe you lose connection to your data but sit in a different jurisdiction. And then you have a way to run your own critical infrastructure with a solution with data kind of safe within your own country or region. So we see this as a kind of global trend right now, with many industries that somehow are considered critical for the day-to-day running of a country. And so this is actually a much wider problem to solve than just climate.
Gosh, love it. I always try to whenever we're talking technology or platforms or mesh, I try to then cross over a little bit and look at it from the consumer side. And if I'm managing risk events, you mentioned a couple there, right? Droughts or floods or rising sea levels, or the changing winds in certain areas where I've built a huge wind farm. Those are big risk events that have material financial effects, but also have material people effects, right? And so from a consumer perspective, those are the problems I'm trying to solve. And those problems are not isolated. You can't cut the world out into pieces and say, well, let's just do the analytics in this piece. To do proper analytics, you need to have a global perspective, a global data perspective. And then digital sovereignty, as you're describing, is like, okay, well, we appreciate that. It's going to be difficult to share across certain boundaries. But with a federated approach, I don't have to move the data. Fantastic. With a federated approach, I can do some analytics in country, in some specific countries.
Exactly. Yeah,
and then I can anonymize the data, or maybe I care more about the trends than I do about the details, right? And so I'm able to share the data that I need without violating sovereignty rules, and ultimately help the country that's sharing the data as much as other countries that are asking for the data, so to speak. So everybody benefits from it. So it's a fantastic approach. I don't know if a mesh professional might say it sounds like federated governance in the sense of being able to apply the right level of governance to different countries or different domains. But I think there is a level of many data sets you deal with that are public data that anybody can access. And then there's commercial data, as you mentioned, that maybe require a license. And then there's sovereignty data that may require a very specific access approach. But how do you manage? I know we're going to run out of time, and we're probably way over time, maybe for another session. And I purposely tried to avoid the topic because we would go for another 30 minutes on it. But managing the security and the governance around all that data, maybe just in a couple of minutes, if you wouldn't mind sharing, is what your overall approach. I know we want to drive openness, you want to drive transparency, and I suspect your first principle is open first and then lock. But how hard is it to manage all that governance and security?
Okay, so that's the hardest piece, to be honest, right? So when we look back, you look kind of impressed, and I told you how many data sets we managed to integrate with OS Climate.
I was blown away was the word, yeah.
But so if I'm being honest, the reality is when you have the recipe for federation, it's very quick to do this kind of data integration, assuming that you don't have to deal with the governance aspect.
Right.
And so we have the chance with climate data that we actually have a lot of open access to data set, and we can actually quickly implement those federation recipe. Now in the enterprise, that is not the case. So if I'm being honest, the big issue when you extend this solution to enterprise is really how you run the federated governance, because typically we have situation of different systems have different layer of role-based access control to the data. And so to unify this access is actually an extremely complex matter. So now this is kind of the cool stuff for me as a technologist in OS Climate, is I kind of get a use case to try some new ways and avenue to solve this problem of federated governance.
Yeah.
So if you look at how we've approached it in OS Climate, but we're still doing a lot of work on this. Right now where we are is we have integrated a component that is actually called Fabric. It's an open source project that integrates an open policy engine with the federation layer that Trino provides. So Trino has a very, very granular way to define data access, which is very powerful. The only one problem it has is you need a lot of people to go and manage the data access. So how we solved it, or try to solve it, because I don't think we are done with this piece of work at all. We basically came up with a way to integrate a policy engine for people to declare data access policy in a way that is kind of human readable. And then we integrate this with kind of the technology layer of Trino, which is, now you can, when you query this data domain, you don't have access to this particular column because you belong to team A and not team B. Yeah. So this is where we are now. It's a super powerful construct in my experience. It doesn't mean it's easy to implement in an enterprise.
Basic RBAC principles?
Yeah, so it's tied back to to authorization based on again a project called Keycloak, which is the standard in the industry and in a single sign-on, so to speak. So the moment you authorize into Keycloak, you get assigned to a team, and this team will have a policy that tells you which data you have access to, which data you can read, write, and even manage data obfuscation as well. So data that you can access, but it will be actually scrambled. It also manages dynamically for you. And this is happening at runtime, meaning that you run the query, and I will return to you only the data elements that you are supposed to access. I can literally change the policy in real time. You run the query again 2 seconds later, and now you get the new data, right? So it's fully dynamic. Now, we are not done with this. So we have an interesting project. If there are people who are watching this who are technical contributors who want to help us solve a very, very difficult technical issue, now we've started a project to implement this policy at the metadata level, which means that instead of defining the access to the actual data where it's stored, we actually define it at the level of the data product itself. Okay. And so we can build what we call inheritance, which means if you take some critical data, you feed it into an analytics model and you produce new data. This new data will inherit the access right of the source until the policy tells otherwise. And so that's a very powerful construct in an enterprise situation, because it builds security in your process as well. People can't just take data and kind of save it, save somewhere or produce a new version of it, and then this result into a policy security issue.
Love it. We could talk more about it, and I'd love to take that conversation into ideas of attribute-based access, which I'm sure you guys are thinking about. Maybe that's another show.
Exactly. Yeah, it's a show. It's a show on its own. I think it's a very complex problem.
Vincent, I can't thank you enough for joining the show, for sharing so much. I am very excited to. I keep telling you, I'd love to help out in some way, to be a part of OS Climate. Love what you're doing. Excited about what you're doing. And just to close up, we'll close up with this screen here together. Just summarize for the audience. When we think about the big data meshes, I'm not sure if you'll find one bigger than this. I love that in your approach, you're really focused. One is we can talk specifically about how you're using the capabilities that make sense for you today. I always tell teams that are starting the data mesh, don't try to build everything, right? Focus on what you need right now. And one of the key things that you bought into early was the idea of federated access, right? I love doing and building data products on lakes. If I could build all my data products on lakes, I would do it all the time. That's not a reality. We can't do it all that time, that way all the time, so to speak. And so the ability to federate across a number of different systems, multi-cloud, on-prem, structured, unstructured, is a necessity. So that's the first piece. Second piece then is the idea of then enabling teams to drive a self-service approach, right? Giving them the blueprint or the recipe that they need to kind of start to solve their own problems. They can reuse, they can share, they can improve, but it's that supply chain picture you drew out to say, I'm going to get you from here to here so that you can run from there to there, so to speak. And so I love that concept of self-service. We talked a little bit about federated governance and whether or not that was something we were really doing, but we certainly appreciate there's different governance models applied to some of the different recipes, and the need to think about sovereignty and the need to think about some commercial data sets versus other data sets. And then data products, obviously the output of that recipe is that data product. And so I don't know that we're being honest with friends, that you set out on day one to say, I'm going to go build a data mesh. I think what you said from day one at OS Climate is, we're going to go out and solve a problem. And here are the problems that we have to solve. And then these capabilities, they fit in. So it's a great summary, Vincent. Let me see if you agree that I covered all the key points.
Yeah, I mean, I don't think I could have summarized better.
I'm summarizing what you said. So it's great because you brought it to the table. Thank you so much, Vincent.
Thank you, Adrian.
Great.